All right, ladies and gentlemen, we need to finish this section of notes. Okay, this section we're going to continue to practice together some of the things that we learned on the front side of section 8.1, which is all about three-dimensional figures and their their properties or characteristics or the different attributes that we have learned about them. So first it says draw a polyhedron and then identify a face, edge, and vertex on the polyhedron. So let's look back to our notes. Okay, if you remember, what is a polyhedron? A polyhedron is a solid whose faces are all polygons. For example, a pyramid is a polyhedron because all of its faces are polygons. A rectangular prism or a cube could also be a polyhedron because all of its faces are polygons. So I'm going to draw both. Okay, so you can go ahead and draw them with me for practice. So I'm going to draw a rectangular prism. So we start with a rectangle, diagonal from each corner, and then connect down and connect over. Okay, I'm also going to draw a pyramid. Let's do a square pyramid. And so you put a dot up above your square. I just kind of tilted my square to the side. Put a dot up above it, and we're going to connect each of the line or each of the corners to that dot. Okay, and we're going to identify a face, edge, and vertex on the polyhedron. Okay, so this right here is the face. It's the flat side of a polyhedron. Oops, sorry, not flat. The face. Okay, what about the edge? Okay, let's see if we can identify an edge. The edge of a polyhedron would be where where two of our faces meet. So any of the lines on my polyhedron are called edges. Okay, an edge. And the vertex is where three or more faces come together to form a point. Okay, so we could draw a vertex might be right here at the tip of my pyramid. It's called the vertex. Okay, very good. Now it says draw a triangular prism, a rectangular prism, a rectangular pyramid, and a triangular pyramid. How many faces does each of them have? Okay, so first we need to draw a triangular prism. So remember, a triangular prism has two triangle bases. Okay, two triangle bases. And the lateral faces are all rectangles because it is a prism. So if I want to show that that is three-dimensional and show the edges on the back side, okay, then we have to use a dotted line, remember that. So the dotted line is going to go through this shape from this corner over to here, this corner or vertex down diagonally, and then this vertex over to that vertex. So now we have shown a triangular prism. Now let's do a rectangular prism. So we start with a rectangle base, and we make our diagonal lines, connect down, connect over. Okay, again, if I want to show the edges and vertices that we can't see, then we do it with this dotted line, not a hard line. So the dotted line is going to look more like that, and then it goes over. Okay, now we want to draw a rectangular pyramid, so that means it's going to have one rectangle base, not two, because it's a pyramid, and then it has a point up top, that's called our vertex, and we have lines from each corner. Those lines are the edges of my shape that meet together at a vertex. Remember, a pyramid has all lateral faces that are triangles. And the last one is we're going to draw a triangular pyramid. So on a triangular pyramid, the base is going to be a triangle. And again, we're going to connect each of the vertices to the vertex that's at the top. Okay? Now it says, how many faces does each of these shapes have, each of these polyhedrons? So we know that the prisms, we have on this prism, our triangular prism, we have 2 bases that are triangles and then 3 lateral faces. So that has 5 faces. Okay, number 2, we have 2 rectangular bases and then 4 lateral faces. So that's going to be 6 faces altogether. Number 3, we have a rectangular base and then 4 lateral triangular faces, so that's going to be 5 faces. And a triangular pyramid has 1 triangular base and 3 lateral faces, so that's going to be 4 faces altogether. Okay, now it says here on our dot paper, okay, just like before yesterday, we have our square dot paper and isometric dot paper, and it says draw a front, side, and top view of each stack of cubes. Then find the number of cubes in the stack. So if we were looking at this stack of cubes from the front, that would be looking at the stack from this side. So we would only see the dark squares that are on this cube. Those are the only faces that you would see if you were looking at it from that side. So if you were looking at it from that viewpoint or perspective, it would just look like 2 squares stacked on top of each other. If I was looking at it from a side view, I would see all of the light colored squares or faces, which means that my viewpoint would only show me what looks to be a 2-dimensional shape that looks like a backwards L. Now, if I have a top view, it means I'm going to only see this gray cube here and this gray cube here, or face, I mean. Okay, the faces that are on the top, if I'm looking straight down onto it. And those would also look like 2 squares stacked on top of each other, just like that. Okay, and the fourth one says, find the number of cubes in the stack. Well, we can pretty easily see that this one has 1, 2, 3 cubes in the stack. Okay, now I want you to pause and try on your own. I've only given you one problem to do here. I want you to draw the front, side, and top view of each stack of cubes, then find the number of cubes in the stack. Okay, so I've only given you the one stack here. Okay, so you need to give me a front view, which is the dark sides of the cubes, the side view, which is the light sides of the cubes, the top view, looking down onto it, which is the gray sides or gray faces of the cubes, and then how many cubes are in the stack. So go ahead and finish that one on your own, and we will come back together and talk about these shortly.